Hi and welcome to this video. Today I wanna introduce you something very special that I got. In my hands you see a microcontroller that has a BLE 5.4 that you can buy it for half of $1. It's very cheap and it has very features that you can use for its price. This is called CH591R. The package is SSOP 16 and it has a BLE 5.4. That is a very good choice for this price. As you can see, I have made a application with it that you can control WS2811 with this microcontroller with BLE. I want to show it how. I just need to put this LED like this here. These LEDs have 3 lines of pin for communication, 2 for power supply and 1 for data. These WS2811s are a little bit hard to work with them. As you can see, they have something like custom protocol to work with. You need to send a specific data at a specified time. For this MCU, it took me quite a long time to identify and write the essential code to make this LED work. I used my logic analyzer to see how much timing I need to work with this LED, and finally I got this working. I want to show you the example quickly. As you can see, I have made this kinda dev board on a breadboard. As you can see, there is a USB that it's directly connected to the MCU that also used for getting the MCU and also powering it. There is a regulator, nothing special, 2 buttons. This is boot and this is the reset. Microcontroller itself, this is antenna. This is 32 megahertz crystal with 2 capacitors. If I say it correct, these are 22 picofarad, and nothing more to say. I am connecting my USB-C cable to it, and also here. As you can see, the power LED turns on. Now what I should do, this microcontroller now advertising itself on BLE. I need to turn on my Bluetooth on my laptop or for your phone. This is web page, so it's work on anything. As you can see, I also design a web page to connect and changing the color of this LED. You should press the connect to device, and you can see here. Let me show you. It's advertised at CH591R BLE. You should connect to it. Okay, and this is now connected. What should you do? You can see the LEDs turn on and it's showing the purple color. I can change the color by pressing here. As you can see, this is score. And if I change the color, the LED color will change to, like, if I choose the red, you can see the LED is now showing red. Let's say purple and purple, blue and like green. This is works perfectly, and this is fun to play. If the camera gets it. Yeah. You can do many projects with this MCU and this RGB LED. Also, this is the first part of WCH MCUs. I started the first episode with this MCU. I really like it and I suggest you to use it. Now let's take a look at the MCU expectation. As you can see, the manufacturer is WCH. The part number we're using is CH591R with this lovely package. As you can see, it's a RISC-V4 core 32-bit, and it's using RV32 iMac instruction set. Also, if you can see here, this thing has a BLE 5.4 that is very good for this price and this package. You can use it for the projects with low space. And as you can see, this version has 26 kilobyte of SRAM, all of them has. If I scroll down a little bit, you can see expectation here. Let me zoom a little bit. This is the version we are using. This is the cheapest one. It has 192 kilobyte 4-core flash. 24 kilobyte is used for bootloader, and 32 kilobyte is available for data flash that we can put custom data and work with it. Something I think like AP-RAM. On all of them, the RAM is 26 kilobytes, which is also good. That when I was taking a look at the BLE code, the minimum SRAM the BLE code is uses is 6 kilobyte, which is good. The 20 kilobyte left for your application. This thing has RTC, 4 timers, 4 captures, and 7 PWM, 2 UARTs, SPI, and unfortunately the only problem this chip has, it doesn't have any I2C. You can see here, this is not marked. They have no I2C at all. It's very not good information, but you can buy the higher end models. You can see this three also have I2C. BLE is included, and also this MCU has USB device, not the USB host, but the USB device is included in this MCU. Also, the minimum voltage supply is very low at this. As you can see, many of them work with 1.7 volt, and these two work with 2.3. As you can see, also the package is TSS-OP16. Okay, let's take a look for more information about this MCU. This is also very low power consumption. As you can see, in idle mode, it uses about 1 milliampere, which is kind of good. Also, let me show you something. I have a measurement tool here. Let me zoom down a little bit. That shows how much current and voltage this device is using. It has a in and out. Let me put it here. As you can see, as I said, we have a regulator MCU safe as LED. I gonna first remove the LED so we can measure the power supply and MCU power consumption itself while it's advertising BLE. As you can see, this thing is using about 12 milliamperes, which is when I measured, the MCU itself is using 5 milliamperes, and the rest is for the LED and the regulator itself. It's kind of acceptable, not bad. And also let's connect the LED and measure again. Also, let me reconnect and show a color. Yeah. Now, currently, this is using about 30 milliamperes, which means the LED itself is using 18 milliamperes, which is a lot of current. This is also for measuring, and Also, let's look at the LED itself. As you can see, this is made by World Semi, yes. WS2812B, and the package is 5050. As you can see here, this has 4 lines, and I think most of you have worked with this LED. Okay, let's move on the development environment. All this, the WCH MCUs use Mount Driver 2 IDE, which is a really good idea. I suggest anyone to use this. It's, I think, based on the VS Code. You can see it has a dark mode, of course. You can see this is very good option, and the IDE itself, it compiles and also can upload the code on the MCU itself. If you use the the programmer, this is the official WCH programmer. You can buy for like $2 or $3 based on your location. This doesn't have very something special. It supports SWD. It supports also UART, and it also supports what kind of JTAG is. Yeah. For most of the microcontrollers of WCH, you can program them with SWD, but the thing is, most of them can program with WSD 1 pin. It means for programming and debugging this thing, you only need one pin of SWD. How it works is for like, I have example here. And on this device I have used CH32 006, if I say yes, and this only connects here. As you can see, I have only one pin of the SWD connected to this, only the SWD IO. You connect this to the SWD IO of this, and this is work. This is gonna work. You can also use the 2 pin and 1 pin. Also, let's take a look more for the IDE. I wanna show you how to like make a new project, Mount Driver project. It has a list of all of the MCUs that is currently available for purchasing and using. You choose your family of microcontroller, and here you choose the specified one. You can name your project, and clicking the finish will create a project. It's pretty straightforward. Also, on the WCH official site, you can download an extended version of the SDK. Like if you want to work with the BLE, you have to download that, and let me show you. Not here. Yeah, this is the extended version of the SDK for this family. If you go to the exam folder, you can see a bunch of exams and the BLE library also here, and examples are ready to compile. You can like click on one and open this Mount Driver Project Studio. Now let's move on the computer itself, so we can code it a little bit fitting, and I wanna show you the environment more. So let's move on the yeah, we are back to the computer. This is the thing you will see when you open the project. We have few folders here. This is the app folder. You can see the main codes are here. We have the main script, BLE, that you can set up things here, adding characteristics and more. The VM20 device, for example, you can set the model number, serial number, firmware version, hardware version, software, and go on. On the BLE.C, you can set the device name, what kind of name to advertise. Also, the scripts and codes here is a little bit changed by me. If you open for like the examples of the official WCH, this is a little bit looks different than this. Nothing important is changed. I like changed some of the files name, changed some settings, and so on. As you can see, as I said, and you can set up your device name here. There are you can also set password for your BLE. You can add callbacks here, like the advertising, connected, waiting for, advertising, error, disconnected, and so on. Also, we have the real callbacks, like a characteristic gets some data, and this is the main callback. On this function, as you can see, this is my characteristic for changing the LED color. When the web page sends the color of the data LED, it's 3 byte RGB. I get it here. I save it in a buffer, and I check if it's really 3 bytes. Some debug, and this is the main code for the WS2812B code. As you can see, I set the code here, first byte, second and third byte, and finally show code. The info service, nothing so much, and the get profile, here you set your service and characteristic, UUID, and some description. You don't need all to understand all of the code here. You need to just change it a little bit. This is for BLE and in drivers. This is the code for LED driver. It took me a long time to the time it took me to get these lines of code like 4 days. I was testing how much waiting I need to send to LED to work. Two operations take about 375 nanoseconds, and target is 350 with 150 teralines, also for high bit. This code uses buffer to send LEDs. As you can see, you can add many LEDs as you want, and sending color for each other. All of this code is available in my GitHub repo. I will put it in the description. You can download it, and this is basically the same thing I am showing to you. On the utils, there is nothing so much, just a simple function to show the free SRAM, and that's all. One thing that you wanna deal with if you want to work with more the BLE, this is the config here. There is some information about the BLE setting. For example, this is where you set BLE memory heap. The minimum is 6 kilobytes. As this is explained here, this is the minimum. This is I think the MCU. Yes, this is the MCU for the BLE 5.4. The maximum is 516. Here this is explained here, 24 to 516 can be set. This is also for buffer, the tx num event, nothing to do. I have changed these, I have changed all of these that was in the SDK. You can also set a specified MAC address. If I go to here, this is yeah, you have to take a look at the codes. I think yeah, this is if you want to define the MAC address yourself, you have to deal with this code. There is nothing more to explain. This is the API of the SDK. You can read it, and I think very more. Let's move on this WCHISP Studio. As I say, if you use the official programmer, you need to go to the Flash and download configuration. As you can see, you can choose your microcontroller here and applying whatever you ARM your RISC be using. This is pretty straightforward. Like if you wanna compile your code, you press the F7, it will compile it, and if you put the F8, it will upload it with the microcontroller if using the official programmer. I have not connected to it, so it gives me an error. The official programmer is used for UART and SWD and the JTAG. Most of the WCH MCUs support many ways to program, this is the cheapest one we are working. Supports UART, that unfortunately I tried a few times but I couldn't upload it using that. But I used the USB way. I connected you can see here UD plus and UD negative to directly to my computer. No caps or resistors needed, and this works fine. Note that the pin PB22 is the boot pin. That's not mentioned here. Like if you open this programmer and if you click on this, it will explain here the CH591F and R. The boot pin is PB22, and the second boot pin is PB11. You can also choose it here. I wanna also show you how to work with this. First of all, when you open this is probably Chinese. You have to change it to English here. The WCH factory, the one of its benefits, it really has a English version of everything, data sheets, documents, IDE, and studios. Also, when you open this, you have to choose your MCU family here. Like you have the ARM ones or RISC ones, BLE, and go on. For this MCU, you have to choose this one. When you choose this one, this page will come. You have to select the chip series. This is CH591X, model CH591, and you can also choose the programming way via serial port or USB. How you gonna program it? Let me show you. Let me connect the device. If you want to upload the code to the chip, here in the object file 1, you have to choose the hex file in the object folder of the project, and after you choose it, you make sure it's enabled. I wanna program it using USB, so I have to choose USB. Let me connect the MCU to computer. If you purchase this MCU for first time and didn't program it yet, When you connect the MCU to the computer, there is no main code. It jumps to boot. So for first time, you will just need to connect it to your computer and upload the code. But for the second and more times, you have to connect the boot pin to the ground. As I said, the pin PB22 to the ground. While it's connected to the ground, you can connect your MCU to the computer. I think I missed it, yes. Let me try again. Yeah, it's identified. As you can see, it's showed in the dev list. You can also press this button to whenever it connects to connect the MCU to your computer, it will upload it, and you have to choose correct hex file, and if you press to download, it will start to download. The compile and download time is very fast. I really appreciate things they have done, and the code is uploaded and you can do whatever you want. So this is for today, there is nothing much to say. Thanks for watching and see you next time.